Day 482 of doing a LeetCode problem. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3446, sort matrix by diagonals. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n square matrix of integers grid. Return the matrix such that the diagonals in the bottom left triangle, including the middle diagonal, are sorted in non-increasing order, and the diagonals in the top right triangle are sorted in non-decreasing order. All right, y'all, so that may sound a little bit confusing, so let's go ahead and take a look at these examples to make sure that we are doing this problem correctly. Now, first thing I just want to say that non-increasing order just means decreasing order, and non-decreasing order means increasing order. I don't know why they wrote it like that, but they did, and that's what we're working with. So let's go ahead and take a look at these examples. So in example 1, we have our input grid equals a 2D array of integers. First array or row being 173, next one being 982, last one being 456. Now, as you can see, each one of these arrays inside of this initial array represent a different row. So, for example, this represents row 1, 173. This right here represents row 2, 982, and this right here represents row 3, 456. What we want to do is we want to sort the diagonals according to these requirements up here, right? So the diagonals in the bottom left triangle, including the middle diagonal, are sorted in non-decreasing order or increasing order, or decreasing order. So what that means is, as you can see in this explanation, first we have, when we go in the diagonals in the middle, right, in the middle counts as the bottom left triangle, we have 186. We want to sort this 186 in decreasing order. So when we look over here, you can see it's 861. It's no longer 186. So that's what we're doing. We're sorting it so it goes 861. 9.5 is already decreasing, so we don't have to change that. 9.5 is already decreasing, and 4 is already the same. Now, in the top right triangle, we have to sort it in non-decreasing orders or in increasing order. So right now you see we have 7, 2. We need to sort this in increasing order. That's why over here it becomes 2, 7, and then we could leave the 3 the same as is, right? So in the end, the output will be 823 will be the new top row, 823. Then the middle row will be 967 right here, and then 967. Then the last row will be 451, just like this. And this just gives us a visual representation of how it would look after we sort it. So once again, we just took this 186 and we sorted it in decreasing order. So this become 861, right? 861. Same thing. This was already decreasing, so it's 9.5, 9.5. 4 can stay the same. Then the top right, the top right, we need to sort in increasing order. So this becomes 2, 7, right? 2, 7. This could stay the same as 3. This could stay the same as 3. And this is our new square grid that we have created after we sorted the diagonals properly. So just in case that didn't make sense, let's take a look at example 2. Example 2 is a little bit more simple because it's just less, it's a smaller grid. So in example 2, our input grid equals a 2D array of integers 0, 1, 1, and 2. Once again, this represents the top row. This represents the bottom row, right? 0, 1, 1, 2. Boom. Our output is 2, 1, 2, 1, 1, 0. So now you see the top row is 2, 1, bottom row is 1, 0. Once again, this we have, we're looking at the diagonal. So the diagonal starts 0, 1. That should be, since it's in the middle, that counts as the bottom left triangle, which means this should be sorted in decreasing order. So we just moved the 2 to the top and the 0 to the bottom. So now it's in decreasing order. 2, 0, and the 1s can stay the same as they already are. So in example 3, it might be a little tricky, just in case they try to throw a trick our way where there's only one cell or one square. Our input grid is equal to the 2D array of integer 1. We just have that 1. Then the output is the same thing, 2D array of integers, and that array is still just 1. Explanation says diagonals with exactly one element are already in order, so no changes are needed. All right, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Solution is not that difficult. Now, the first thing we're going to do is we're going to get the number of rows and columns. Now, in this case, since we're working with a square, we really just have to get the number of rows because the number of rows will equal the number of columns because we're working with the square. So we could just say let n equal grid dot count. So once again, we don't have to do the grid square bracket 0 dot count to get the columns because the columns are equal. It's the same amount of columns as it is rows because once again we're working with a square. So it's 3 rows and 3 columns in this example. So then we need to check if the matrix has only one element, then we can just return it as is. Similar to an example 3, we're going to handle that case with a guard statement. We're going to say guard n is greater than 1, else we could just open up the brackets and we could just return grid. Boom, just like that. Then we're going to make a mutable copy of the matrix. So we could come underneath this, declare variable. We could call this one m, and we'll just set this equal to grid, and that's going to allow us to mutate grid. Now, we're going to sort all the diagonals above the main diagonal, so the top right half, or above the top, we're going to sort all of the diagonals above the main diagonal, so the top right half in ascending order. So to do that, we're going to say for I in 1 dot dot up to n, we're going to open up the brackets, and I is the starting column index. We're going to skip 0, that's because that's the main diagonal. Then we need a temporary array to store the diagonal elements. So we're going to come right here, we're going to declare a variable, we can call it diag, and we can set that equal to an array of integers. Boom, and then put the parentheses outside. Then we're going to collect the elements from the diagonal that start at 0, comma I and goes down right. So we're going to say for d in 0 dot dot up to n, or excuse me, open up the parentheses, n minus 1. Then we're going to open up the brackets and we're going to say let row equal d. We're going to say let call equal I plus d. Then we're going to come underneath that. We're going to say diag dot append, open up the parentheses, m square bracket row, square bracket call. Boom, just like that. Then we come underneath this for loop, but still inside the other for loop, and we are going to sort that diagonal in ascending order by saying diag dot sort. Put the parentheses. Then we're going to put the sorted values back into the same diagonal position. So we're going to come underneath this and we're going to say for d in 0 dot dot up to, once again, open up the parentheses, n minus 1. Come outside of that, open up the brackets. We're going to say let row equal d, let call equal d, or excuse me, I plus d. Come underneath that, we're going to say m square bracket row, sorry y'all, and square bracket call. We're going to set that equal to diag square bracket d. Boom. Now we need to sort all diagonals below the main diagonal, including the main diagonal or the bottom left half in descending order, right? So the bottom left half is in non-decreasing order, aka descending order. So to do that, we're going to come right here. We're going to say for I in 0 dot dot less than n. We're going to open up the brackets, and I is once again going to be the starting point for the row index. And then, so we need a temporary array to store the diagonal elements. So we're going to come right here, declare a variable called diag again, and we are going to set that equal to an array of integers. Come outside of that, put a parentheses. Then we're going to collect elements from the diagonal that start at I, comma 0 that goes down to the down to the right. So we're going to say 4D in 0 dot up to, open up the parentheses, n minus 1. Or excuse me, not n minus 1, n minus I. Boom. Sorry, y'all. All of these should be n minus I, not n minus 1. I was tripping. Forgive me. Sorry. Now, let's keep going. So this should be n minus I. Then we're going to open up the brackets. And once again, we're going to say, or this time we're going to say let row equal I plus D. And we're going to say let call equal D. Boom. Come underneath that, we're going to say diag dot append, open up the parentheses, m square bracket row, square bracket call. Then come underneath that, we're going to sort the diagonal in descending order. So this time we come underneath this for loop, but still inside the main for loop, we're going to say diag dot sort. This time we're going to open up the parentheses and say by colon and put the greater than sign to sort in descending order. Then we're going to put the sorted values back into the same diagonal positions once again by coming right here and saying 4D in 0 dot less than, open up the parentheses, n minus I, open up the brackets. We're going to say let row equal I plus D, let call equal D, say m square bracket row square bracket call equals diag square bracket D. Then all we have to do is return the modified sorted matrix by coming right here and saying return m. Boom. Let's run it, y'all. Let's make sure it runs correctly. Let's see, and it's accepted. That's what I'm talking about. Let's go. Let's run it. Let's submit it. See what happens after we submit it. First try. That's what I'm talking about, y'all. 8 milliseconds beats a -% of users. Not sure what that means, but hey, it's accepted. We made it to the end. So with that being said, make sure you get one more look at the code. This is the top part. This is the middle part, and this is the bottom part, y'all. And with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.